So let's finish this, jump to subroutine and return. Whenever you press this generate hex, it will go ahead and generate the hexadecimal for the microcode compression ROM and also for the microcode ROM. So it takes about 20 seconds, 30 seconds to generate this, so it's not the quickest bit of VBA code I've ever written. I could probably make it a little bit quicker, but I'm not really that bothered. It does what we need it to do. So whenever it's done that, you can put in, click on this to export the code. Now I've just exported the code to some file here. Now it's going to be exported to, in this instance, a file which will be called compress. Okay, and in fact no, that's not right. It's going to be exported to one that's called microcode. Okay, so this is going to be the microcode, and then whenever you export the other one, it's going to be exported to a file that's called compress. Okay, so one's for the compression ROM and one's for the microcode ROM. Now, whenever you've gone ahead and exported these to wherever you've decided you want to put them, what we'd have to do is you'd have to come in here and we can press reset on our machine. So I'll just grab the machine and pull it over a wee bit so we can see it better. Okay, so well, that's at least this a bit better. We can see more of it here. Make it a wee bit smaller. Okay, so what we can do is we can press reset on the machine. So that's the machine reset. When we drop down in here, now you won't need to do this all the time. It's only whenever you decide you want to update any of your microcode or add new instructions. So you're going to have to get into the microcode ROM, and you've got the compression ROM here. So you can go in here and you can go clear contents, get rid of the old contents here, and clear contents. And then you get into here, edit contents, and then open up the file, which is going to be wherever you saved it to. In this instance here, I've got in this file here. So this is going to be the compression ROM, which is just a file here that's called compress. Okay, so open this, and you can see you actually have to press version 3 hex. Right, and then I press OK and close window, and you can see it's populated all of the values here. Okay, so these are the start addresses for each of our instructions. And then you can get in here and press edit contents and open, and then we can open the actual microcode. And again, I've got it sitting in this same file here, and it's called microcode. And you can see the microcode here. Okay, and obviously you can see the thing about the microcode is that it runs all the way along here. Okay, there's not any gaps in between. Okay, and it leaves up free space at the end here for more and more instructions. Okay, so that's it basically loaded up, and it's a ROM. Okay, both these are ROMs, so whenever you close it down, they'll still be there the next time you go to run any code. But of course, whenever you run the code, you're actually going to have some code in the RAM to run. But before we can even do that, what we're going to have to do, as we mentioned, the operating system will have to stick in a value for the beginning of the stack, and that's what's in here. So this is the ROM here, and this is going to contain stuff for our operating system, and it's also going to contain some routines that we're going to be using quite regularly. So this routine here is actually a get character routine, so it grabs a character from the keyboard and saves it to the memory, and there's a put character as well, so it takes the character from the memory and it will place it into the screen. Okay, so and we, as the process goes on, we'll build up more and more of these functions here, and then whenever we write our assembly code, we can use our jump to subroutine to go into these subroutines to run this code for us, instead of continually having to write bits of code that we're using all of the time, which is what would happen in an actual computer. So what we would have to do is we'd have to make sure that the ROM, first of all, we loaded up a value into the stack pointer, and that's what these here do. Okay, so in this instance here, the 0108, that's actually a data command, so it's telling us to put the value F0. Now F0 is going to be the bottom of our stack, and it puts that value into one of the registers, and then after it's put the value into the register, we into the actual stack pointer. So that 0108 puts that data into the stack pointer. So once it's in the stack pointer, then what we'll have to do is we want to actually go and jump to the first address location. So the first address location here is going to be the value 8000. Okay, so that's 8000 in hex. So that's the first address location of the RAM. So if you like, these two little commands we've got here are the start of our operating system. It's what happens initially as initial setup whenever we go to start running our CPU. So not a big operating system at the moment, but it actually will get a little bit bigger as we go in and build some more functionality. So this will actually happen, and I've got this coded in here at the moment. Now it doesn't matter if you look and say, well, I don't know that this is the code for a data for the stack pointer, and I don't know that's the code. Fair enough, you won't know that that's the code, but if you've got the spreadsheet and you run the spreadsheet, you will be able to see, and you'll be able to see what the codes are. And also, I have an assembler already generated in Python, but we'll get to that later on. You know, we've still got all these other things to add into the mix. So we're going to put the value, start value in the stack pointer, and we're also going to jump to the beginning of the program. So let's continue with this. So we're going to need a program to actually test the jump to subroutine. Now our programs are going to go into the RAM, and this is our RAM element here. Okay, so we're going to load a program up in there. Now, in order to load the program up, we have to know what it is the instruction does. So we're going to have a jump to subroutine, and it's going to be to the value held within a register. So it would be, for example, JSR space R0 or JSR R1, R2 or whatever. So what it's going to do is it's going to jump to the subroutine, and the address for that subroutine is held in one of the registers. So before we can test it, we'll have to actually put an address in a register. Okay, so in order to put an address in a register, we're going to have to use the data command. Now, don't get worried too much here about the numbers we're putting in here, because it'll all become a bit transparent to us once I've showed you the assembler. Okay, but I've not got the assembler here for you, or I don't want to show you at the moment. I want to work through all of the little details first of all before we get there. So if I'm in the second page of this spreadsheet here, I can actually find, if you go up to the top, you can find the data command. There's the data command here. So if I'm wanting to put, say, a value in a register, then I can use this data command here, and it's actually got the opcode 1, so it's actually 01. Okay, so there's the 8 bits for this bit here. It's 01, and we're going to put the value into register B. Okay, so register A would all be zeros, and if we're going to put it in, say, actually register 0, we'll just make that register B all zeros as well. So we can actually use 0100. Now don't worry too much about these numbers, it's just for me to show you how this thing works. Okay, So we can put that value in here. Now, I don't know if you can quite see this. I might just open this out a little bit so bring it over. Okay, so there we go. So I can get in here and I can put in, actually just type it in, click on it, 0100. So that's the data command. Now I'm going to put a value into register R0. Now the value I put in is the actual jump address. So this is the address we want to jump to. So if we want to jump to, let's say we want to go to 8020. Now remember the RAM actually starts at 8000, okay? So we're going to go 802 to position 8020. So that's ultimately where it's going to jump to. So what we'll do is whenever it gets to 8020, so we can come in here and find 8020. Now it's maybe a little bit smaller, but maybe just make it out. What we'll do is we'll put the end command in. Now the end command at the moment there is 5800. Okay, again you can get that from that same spreadsheet. So that's our simple code here, but still we have to actually now go through and do the jump to subroutine. So the jump to subroutine is going to be given by the 1300. Okay, so that's our actual code for that jump to subroutine. So we've got everything in here that we need in order to start the program. So if we go up to the top level, now I'll need to move this back again so we can see. Right, so we're at the top level here. Now, as I work my way through this, we'll see each of the values changing. So let me just start this here, okay? And we're going to set up the stack. So we click in here and we can see the instruction register. Again, it's a little bit off of the edge of the screen here. I'll make that a little bit smaller. You can see the instruction register here is this value here. So if I continue with here, this is the value that's held inside the ROM, which puts the value of the stack pointer at the bottom of the stack into the stack pointer. Okay, so it's going to put the value FFF0. So this is the bottom of the stack. So we'll set up the stack using our operating system. Now, once we've done that, we're going to jump to the very first line of the code. So we've got the jump command here, which is this 0C00, and it's going to jump to a position. So it's going to jump to position 8000. So now it's going to position 8000, which is in here. Okay, so it's actually going to go to the very first position within the RAM block here. Now, whenever it goes to that first position, it will find our program that we've just written. So the program that we've just written is going to be the data command, and the data command is going to put a value into register R0, which is our jump address. Okay, so now we've got that value in there. We're now going to run through our jump to subroutine. So our jump to subroutine is the 1300. So now we're in the jump to subroutine, and this is where we'll go and we'll look at it in some detail. So what I can do is, if you note these the clock here, now whenever they all go, whenever I'm in that position there where we're at the clock enable, what we do is we can click through 1, 2, 3, 4, and we get back to that same point again. So if we get in and have a little look in here, and we'll look and see where we are within our control unit stepper or counter. Let's have a look and see. You can see we're actually, if I open it up a bit, you can just about see it here. We're actually at position 1, okay, because you can see that the little dot here is actually a darker green. So we're actually at position 1 here, okay. So the position 1 in our count and our counter is going to ensure that we are at the first part of our microcode. So let's just run this on just a little bit further. So we'll move on until all of them are actually enabled. So now we're actually truly at that position 1 in our microcode. And you can see here that we're starting to get our lines have actually appeared in our microcode. So what we're going to have is we're going to have the stack enabled, which was the first line of our microcode. So we put the value of the stack onto the bus, and then we set up the ALU. So the ALU is 1001, and these are the 4 ALU values here. And we also set the value in the accumulator. Okay, so then in effect what we've done is we've subtracted 1 from the stack, and we've stuck the value into the accumulator. Now you can actually see these things if you actually go right down into the microcoded ROM. So if you drop down in here, you can see here that the first value up here is the opcode. So that's just the opcode for our jump to subroutine. So if we went to the spreadsheet, you'll see that this is the opcode for our jump to subroutine, and also we've got our addressing mode. In this instance, the addressing mode was a value 11. So we could actually just drop into the spreadsheet, and if we went in here and we found our jump to subroutine, and I'll bring this up so you can actually see it. So there's our jump to subroutine here, and you can see that the value here is 30100. Okay, so that's the first part, and then the addressing mode here is the second part of the instruction, which is the 11. And then you will see the steps. So the steps are going to be this step here, which is 0, 1, 2, 3, 4. Okay, so there's actually 5 steps in total. So if we go back into here, you can see here that's our opcode for our jump to subroutine, and these here are our addressing modes, and these choose or find the starting address of our jump to subroutine. So now we've got the starting address of the jump to subroutine. It gives us the starting address here within our within our ROM. Now you can't quite see it here, it'll be somewhere down here, and it'll be actually, there it is there. So we're actually sitting at that starting point. And now once we've done this first one here, you can see these here are just all 32 bits. So each of these little bits here is actually 4 bits because it's in hex. So these here represent all of the sets and all of the enables for all of the registers. And you can see here it's passed through the first lot that we need in order to generate this jump to subroutine. And this here is going live here. So one of these will be the stack enabled. Another 2 of them here will be for the ALU, and the other one here will be for the setting the value in the accumulator. Now what happens is when we go to the next point, this here starts counting. So it's going to start counting up, and it's going to move on to the next line, which is going to be this position here, and then this position. And as it jumps into each of the positions, the values for the sets and the enables on the right hand side here. Okay, so it's just off the edge of the screen here. I should have made it a little bit smaller. Okay, so the values of the sets and enables are going to just change. So let's see that happening. Again, it takes a little bit of time in the video to work our way through this, but it's well worthwhile seeing it at least once. So we can go into the next line. Go 1, 2, 3, 4. So they're all now enabled. So we should be on to the next part of the control unit. So we're now on this part here. Okay, so we're at this point. So that's the second part. In the second part, we've got the accumulator gets enabled. So we then take the value, which is the stack pointer value. We've subtracted 1 from it, and then what we do is we set it back into the stack, and we also go into the memory address register and set it in the memory address register. So all this is doing is just continually going through what we've seen previously in the spreadsheet. So it just mimics what's in the spreadsheet. Now, I don't want to go through every single one of these, but you can see here it's now subtracted 1 off of the stack pointer. So the stack pointer was sitting at F0, and then when it subtracts 1 off, it goes to 1 less, which is FFEF. So now we've done that there, we can head on and continue with the rest of the code. So 3, 4, we've got that one here, and I'll go to the next one, 2, 3, 4. We'll see where we're actually at in the setup here. So what we've done here is we've taken, it's a wee bit small here. I'll zoom in and I'll move it along a bit for us so we can see it. Okay, so you can see here that what we've done is we've put the return address into that position in the stack. So that's the position that we counted to in the stack, where the stack pointer points to, and we've put the value 8003 because that's the return address. Okay, you know, the first value was the data, and the second value was where we're going to jump to, and the third position in our memory was the jump to subroutine. So that's 8000, 8001, 8002, and the return position will be the very next one after that, which is 8003. So we've saved our return address. Now, what's going to happen now is we're actually going to have to go ahead and do the jump. So we've saved all the return address and we head up to the jump. Now, whenever we jump to the final position, it's just going to have the stop command. So the stop command will come in, you see 5800, and finally it will just stop. And that's us worked through that process of the jump to subroutine. Now, we haven't gone through the return, but what we could do is we could go in and take the value. I'll make this a little bit, shift this over a bit. I have to keep moving it back and forward here, just simply to capture everything so you can see everything that's happening. So what we could do is we could actually get into the code here, and where we set up the return, we set up the stop. Rather than having the stop position there, we could actually put the command for the return, okay, and the return would just jump back into the actual return address position, okay. So we could replace this 58,000, which is the stop, and we could replace that with the return, and it will just jump back to the position that we found in the stack, which is 8003. Okay, so that's went through that process. It's a bit awkward to describe it and me sitting here physically doing this, but what you could do is you could take these numbers and you can take the values which are, you can take the program which is in the resources section, and you can run through this simulation for yourself and you can see everything changing. Just use the same numbers that I've used and just put them into the RAM and just run through the simulation, and you'll be able to see all of the ones and zeros all changing. It's really quite beautiful. So that's all I want to talk to you just now about the stack. Don't worry too much if you think there's a lot of kind of details that we're still to see. We'll see them as we move on and look at the addressing modes, and we'll work through another couple of these kind of examples. And I suggest that you open it up and have a little play with it yourself. Okay. So I think that's all for this video. On the next video, I think what we'll do is we'll start looking at the addressing modes. So we'll have a few videos covering addressing modes. So thank you for listening. I'll get you on the next video. Goodbye.